Welcome back, students, to our software engineering and testing paper. So, in the basis of all the software engineering developmental models we have learned already, we now move on to the spiral model, the last model that is given in your unit 1. So, the spiral model greatly extends all the other models: prototyping model, waterfall model, evolutionary model, etc. So this is an extension of all the previous models, all the models that we have learned in our previous classes. So but this is a different one. The model get its name from the appearance of its diagrammatic representation. The diagrammatic representation of this model appears like a spiral with many loops. The exact number of loops of the spiral is not fixed. It can vary depending upon the project. So the number of loops can vary from project to project. Each loop of the spiral is called a phase of the software process. We learned what is a phase of the software development process. Here, each phase forms each loop in the spiral model. This model can handle unforeseen risk. So, the model is proposed to be a more flexible one comparing with the other models. Because the exact number of phases through which the project is developed is not fixed, the project manager can take decision of the number of phases or the number of spirals, loops involved in the model. So it provides great flexibility for the developmental team, and it achieves the benefits of the prototyping model as well. Building a prototype can handle much more change request at any time of the developmental phase. So for each phase, prototypes are built, and every phase are implemented using the waterfall model. Over each loop, more features, one or more features of the product are elaborated and analyzed. And even in this model, we identify the core features also, core and core features of the software as well. And this is very effective in handling risk at any point of time, because the risk at any point of time are identified and resolved by implementing a prototype. So this is the spiral model performs good in risk handling. As in figure, the figure shows the spiral model of software development. Each model, each phase in this model is split into 4 sectors, a different representation of the model. And the model is split into 4 sectors. The sectors are said to be quadrants. In the first quadrant, some features of the product are identified, and the risk involved at that point will also be identified, and we identify how crucial the risk will be for the overall product development. So implementation of the identified features is the objective of the phase. So the objective of the phase is the implementation of the identified features. The objectives are investigated, and objectives are elaborated, and these objectives are analyzed. And based on the identification, elaboration and analysis of the objectives of the product, the risk involved in meeting the phase objectives are identified. So at the first phase itself, we identify the core features of the software, and implement or elaborate these features and analyze the features, as well as we analyze the risk involved in at that point. So identifying the risk involved in meeting the phase objectives, and then alternative solutions possible for the phase under consideration or proposed. So this forms the first quadrant in the spiral model. So at the first quadrant itself, first quadrant of the first loop itself, the team analyze and identify the features of the software, and they also analyze the risk involved in meeting the objectives of the phase. So at every point of the developmental time, they could be well aware of the risk involved in the development of the software, and alternative solutions for risk handling will also be proposed at each and every phase of the model. So the first phase itself forms a very important one, because it determines or identifies the objectives, elaborates the objectives, and the objectives are even analyzed based on the risk at that moment, and alternative solutions for handling the risk, as well as alternative solutions for implementing the objectives are determined at the first quadrant. And second quadrant, the alternative solutions are evaluated to select the best possible solution. So at the first quadrant, we determine the objectives, analyze the objectives, elaborate the objectives, and the risk to be handled at that point will be identified. And at the second quadrant, we identify the alternative, identify and evaluate alternative solutions. A best possible solution will be chosen. The solutions are evaluated by developing an appropriate prototype. So it takes the advantage of the prototyping model also. So the risk and the solutions are evaluated by developing an appropriate prototype. During the third quadrant, the activities of the third quadrant consist of developing and verifying the next level of the product. So at the third phase, the next level for the product will be developed. At the end of the third quadrant, the identified features have been implemented and the next version of the product is available. Activities during the fourth quadrant concern reviewing the result of the stages that is visited so far. That is the next version of the product, and this is implemented with the customer and planning the next iteration around the spiral. The radius of the spiral at any point would represent the cost incurred in the project. So it facilitates the estimation of the cost also. The radius of the spiral, by identifying or measuring the radius of the spiral at any point represents the cost incurred in the project. So far, that is how expensive would be the software development. And the angular dimension would represent the progress made so far in the current phase. So we can at any point of time measure the cost and how the software development process progressed so far in the current phase, up to the current phase. In the spiral model of development, the project manager dynamically determines the number of phases as the project progresses. It is not determined at before the starting of the developmental process at each phase. Through each phases, the project development team or the project manager can determine or take a decision on how many loops will be needed to complete the software. So the project manager needs to play an important role in case of the spiral model. For a specific project, he may needs to take certain decisions depending on the features to be implemented for that project. So this project, this spiral model, as I said earlier, the spiral model performs good, very good in risk handling. It can handle the unforeseen errors, unforeseen risk. What is a risk? A risk is any adverse circumstance that might hamper the successful completion of a software project. So any situation, any adverse situation throughout the development of a software can be considered as a risk. For example, slow data access rate can also be considered as a risk factor. A slow data access rate from a remote database, of course it could be a risk in such a software. This risk can be resolved by building a prototype of the data access subsystem, and we can experiment with that data access subsystem before implementing the original software. The spiral model provides direct support for handling such risk by providing the scope to build a prototype at every phase of the software development. So during every phase of the software, spiral model provides a provision for developing a prototype, and by developing the prototype at each phase, we can cope with the risk in a certain manner, because it provides more provision, or it provides faster and inexpensive alternative solution scheme by applying caching scheme or communication scheme. And we can know unforeseen risk by developing a prototype at each and every phase. So it is said to be a good model in handling unforeseen risk. As we said, the phases of the spiral model, like that we seen in the figure. Each phase in this model is split into 4 sectors or quadrants, and in the first quadrant, a few features of the product are identified based on the severity of the risk. That means how crucial the risk is to the overall product development. And we then implement the identified features, investigated, elaborated and analyzed the objective of the phase, and then the risk involved in meeting the phase objectives are identified. Also, alternative solutions possible for the phase under consideration are proposed. And at the second phase, second quadrant, the alternative solutions are evaluated, and we select the best possible solution from them. The solutions are evaluated by developing an appropriate prototype. And in the third quadrant, we develop, it consists of developing and verifying the next level of the software, and we implement the identified features of the software. At the fourth quadrant, reviewing the result of the stages that is traversed so far. So fourth quadrant is meant for the reviewal of all the other stages that is visited so far. And at the fourth quadrant, we plan for the next iteration of the spiral. Coming to the advantages and the disadvantages of the spiral model. As we said, the model implements all the features of the waterfall model, prototyping and the evolutionary model. So the shortcomings of all these models are overcome by the spiral model. Yet there is some disadvantages for the spiral model, but the advantages are very high comparing with the disadvantages of the model. The few disadvantages of the spiral model are: the spiral model usually appears as a complex model. It is a flexible one, but it is a complex model comparing with the other models, more complicated one. It is a risk driven and it is more complicated than the other models. As it is more complicated one, it requires a knowledgeable staff. Knowledgeable, well experienced staff is needed for implementing such a model. And it is not very suitable for development of a product as outsourced product. Since the product risk need to be continually assessed, it is not a good one for the outsourced projects. But for certain categories of projects, the advantages of the spiral model can be very greater than its disadvantages. For projects having many unknown risks that might show up as the development proceeds, the spiral model would be the most appropriate development model to follow. So it is much more powerful than the prototyping model, which requires that all the risk in the product should be known at the start of the project, and all risk are resolved before the project development starts. So this is said to be a better one comparing with the all other software models. So we are at the end of the first unit.